Okay, we're moving on to section 7.6 right now. We were in section 7.5 where we were proving quadrilaterals were parallelograms using a two-column proof, and now we're just going to prove the other types of quadrilaterals, whether it's rectangles, rhombus, trapezoids, etc. And so if I take a look at this, what I have here is a chart that has a bunch of different pathways. So if I'm looking at this chart here, I have rectangle, rhombus, square, kite, and trapezoid, and isosceles trapezoid. And if I look at this chart, what it's showing is that if I can prove that something is a parallelogram first, and then I can show that I have one right angle, then I can say that it's a rectangle. So within the proof, I will be proving first, just like in the previous section, that something is a parallelogram. That'll be one of the steps. And then the next step, I'll say I have one right angle, and then I can say the step after that, I have a rectangle. Another pathway I can do is I can say that diagonals are congruent after I prove a parallelogram, and I would have a rectangle. Or, as a separate pathway, I can just say that I have four right angles and I have a rectangle. It looks like a lot of information here, I'll admit. However, if you just focus on one of the pathways, so for the first one here, it's a parallelogram with one right angle, and it's a rectangle, whereas a rhombus is a parallelogram with one pair of consecutive sides congruent, and it's a rhombus. Notice, these are just the definitions of the various shapes. So if you know the definitions, the converse of the definition is really just the pathway to find the various different types of quadrilaterals. You know that a square is just a rectangle and a rhombus. That'll give you a square, so I'll have to do both prove that it's a rectangle within the proof and that it's a rhombus. Two disjoint pairs of consecutive sides congruent, that's the definition of a kite. So all of these have one pathway at least, that if you know the definitions, then you, so exactly one pair of sides parallel is a trapezoid. If you know the definitions from the previous section in 7.1 and 7.2, then you should know one of the pathways here. Trapezoids, and you can go any of these three to get to an isosceles trapezoid. And I think actually the one that's the definition is this one down the middle. Okay, let's move on and let's go ahead and try some of the various types of problems you'll see in this section. Okay, so I'm going to do a couple of proofs here, and then I'm going to get to a certain type of problem that I'm going to refer to as squares. So let's start out with this first proof here. It's given that this figure right here is an isosceles trapezoid, or sorry, is a parallelogram. And what you're trying to prove is this entire figure is an isosceles trapezoid. You're given that you have an angle right here that's congruent to this angle right there, so I'm going to mark those, which makes that an isosceles triangle. And if I look at the pathways or the trees on the front side, the path that I can choose to prove that it's an isosceles trapezoid is, first I'm going to need to prove that it's a trapezoid, and then I'm going to have to prove that one of the things is true. There's three different ways to prove it. I'm going to use, I believe I'm going to end up using that because these are congruent to each other and these are congruent. I'm going to end up proving that the non-parallel sides are congruent to each other. So let's write this proof out. Given that it's a parallelogram, and because it's a parallelogram, I can use the fact that these are parallel to each other as information I'm going to need to prove that it's a trapezoid. So ED is parallel to AC, because if you have a parallelogram, then opposite sides are parallel. And now, because of that, I can say that AEDC is a trapezoid. One pair, opposite sides parallel means it's a trapezoid, gives you a trapezoid. Okay, that's the definition of a trapezoid. And then now I can go ahead and use this information right here. Step 4 is given. Step 5, I know that DB is congruent to DC because of if angles then sides. And now it looks like I gotta set up a little transitive property action here. I know that DB is also congruent to AE. That's going to be because if I have a parallelogram, then opposite sides of a parallelogram are congruent to each other. And now because DB is in both of these, I know that these two are congruent to each other. So DC is congruent to AE using transitive property. And now I can say that because I have a trapezoid and the non-parallel sides are congruent to each other, I can say that AEDC is an isosceles trapezoid. Trapezoid with non-parallel sides congruent is an isosceles trapezoid. Okay, so that would be a way to do a two-column proof for these types of problems in section 7.6. Let's go try another one. Okay, we're on the third page now. Problem number 5. It says that triangle ABC is isosceles with base AC. So you know that these sides are congruent to each other. And it says that ABC is a right angle, so this is a right angle here. And you know that BE and AC bisect each other, so this, hopefully you can see, is going to give us a parallelogram. Okay, so I'm going to put this here in step 1, that's given. Step 2 is I'm going to have a parallelogram, so ABCE is a parallelogram. And again, that's just one of the ways to prove a parallelogram. So diagonals bisect each other. Is going to give you a parallelogram. Okay, and then so from there, I know that if I have a parallelogram with one right angle, that's going to be a rectangle. So ABCE is a rectangle. So if I have a parallelogram with one right angle, it's going to give me a rectangle. Because keep in mind that if I'm trying to prove something's a square, I just need to prove it's a rectangle and a rhombus. Okay, so in my next one, I'm going to say that I have an isosceles triangle here, step 5, and we know that because it's isosceles, AB is congruent to BC. Isosceles triangle. That's two sides congruent to each other, the non-base sides. And then now I can say that it's a rhombus. So ABCE is a rhombus. And the reason why is going to be a parallelogram with two consecutive sides congruent is a rhombus. And now, because I got this step and this step, I can now go down and say that this is true, that ABCE is a square, rectangle plus a rhombus means you have a square. Okay, so that's what the proofs look like in this section. We're going to move on now to trying some of the squares. All right, we're moving back to problem number 4 here. In problem number 4, you have a bunch of things that look like squares. That's why I'm calling these problems squares. And so, even though they all look like squares, they aren't necessarily squares. So here's what I mean by this. You have a problem here, letter A, and you're supposed to identify what type of quadrilateral it is out of all the different types of quadrilaterals that we've done so far. So my recommendation is, for all these problems, identify first, is it a parallelogram? Okay. Does one of the 5 ways that we know how to prove a parallelogram, does that apply in this particular case? And if you look at this first problem here, it doesn't seem to apply, although we can kind of toy with this a little bit in knowing that if these are parallel to each other, then this has got to be congruent to this because they're alternate interior angles, which means that this triangle right here is going to be isosceles, which means that side's congruent to that side. And then if I look at this thing, I can't really prove that these two triangles are congruent to each other. I don't see any way to do that. These two sides aren't parallel to each other, so I know that I don't know if these are congruent to each other. So it doesn't look like I can prove it's a parallelogram. And in fact, I just have one pair of opposite sides parallel to each other, so I know that it's got to be a trapezoid. Now the question is, can it be an isosceles trapezoid? So I have to look at my pathways on the first page and see if any of the pathways work to get me to an isosceles trapezoid. You can ask yourself, are the lower upper base angles congruent? No. Are the non-parallel sides congruent to each other? No, not necessarily. Are the diagonals congruent? You can't really say that. So it's not any of those things, so you know that the best you can say is that it's a trapezoid. Letter B here is, okay, these are parallel to each other, which means this has to be a right angle here, right? These two have to be the same, have to be supplementary, and so this has to be a right angle. This is 110 degrees, this has to be supplementary, so this is going to be 70 degrees. And I can already see that because these aren't supplementary to each other, these two sides can't be parallel to each other. So it's not a parallelogram. So it's going to either be a trapezoid or a kite. I can see from this being one pair of opposite sides parallel that it's a trapezoid. And then I have to identify, are these two sides congruent to each other, or any of those 3 pathways that I can get to an isosceles trapezoid. I don't have any of those pathways, so I just say it's a trapezoid. Not all these are trapezoids. Okay, so for this next one here, you can see that this is going to give you a parallelogram because the diagonals bisect each other. And then you can see that these are congruent to each other. And because it's a parallelogram, I know that these are parallel now. And so this side, or this angle and this angle, have to be congruent to each other because they're alternate interior angles. And these two sides are parallel, which means that this side, or this angle and this angle, have to be congruent to each other. So now you have a parallelogram with one diagonal bisecting an angle. And that means that it's going to be a rhombus. You do have to check to see if it's also a rectangle, and hopefully you can see that if these are different, then that means that this diagonal here, there's no way that that diagonal is congruent to this diagonal right there. So it can't be a rectangle. So it's just a rhombus. Okay, letter D here. You can hopefully see that right off the bat. The diagonals bisect each other, so it's a parallelogram. And it's a parallelogram where in this case, the diagonals are congruent to each other. So I know that it's got to be at least a rectangle. And I can see that both diagonals are perpendicular bisectors of each other. And that's one of the ways of getting to a rhombus. So I know that this is also a rhombus. And if I know that it's a rectangle and a rhombus, that means that this figure has to be a square. Okay, I think I'm going to stop there. Hopefully you're getting a sense of how to approach these. Again, when you're approaching these, check to see if it's a parallelogram first. If it's not, then you can take a look at it to see if it's a trapezoid or a kite, and go from there. Okay, and if you do happen to identify it's a parallelogram, you can try to see which type of parallelogram it is. If you identify that it's either a rectangle or a rhombus, you have to check to see if it's a square. So check first, don't just assume that if it's a rhombus, it's just got to be a rhombus. So hopefully that's helpful, and I'll let you go ahead and try some of the problems on your own now. All right, take care.